Alright, another draft physics video presentation. I think we'll switch to relativity theory, bent space stuff, just for an episode or so. Just because, there was a couple of comments and, it's a tiny part of the Feynman video, but, people just react. How dare you say light is always consistent and always does the same thing? Because we've proven somehow otherwise. Anyway, so this idiot, Fermilab guy, whatever, doctor, whoever, arrogant, obnoxious, religious kook, really. That's all you can say. Why general relativity is definitely right. So I watched the video and it was just, I got to where he got to the Eddington experiment and, my brain just fell out of my head and I couldn't watch anymore because it's just so bad. I mean, they don't even know their own physics. They don't even know the history. They don't know any of the the fundamental facts upon which it's all built on. And one of the facts that it's not built on is the obvious one, that all the forces move the same speed. So it's not the speed of light, it's the speed of force. And if you say those words a few times, the speed of force, you kind of know that all of these things have to be the same thing because they're all moving the same speed. So whatever your silly theories are, you really do have to figure out that the real universe, okay, has this stuff moving the speed of light, the energy, okay, is all moving the speed of light. The stuff that's forcing the matter to go or forcing the matter to do what it does. It all becomes kind of easy to put the little A, B, C blocks in the right order then, and not have to believe what these religious kooks believe. And it's just that. It's just a religion. So, let's read what he says. Of the known fundamental forces, gravity stands out. Well, it really doesn't. Okay, it looks just like the other kind of motion. It looks a lot like what magnets do in terms of the attraction part. It has a lot of similarities, very similar in a lot of respects. It's just matter moving, and there seems to be an invisible hand doing the moving, that's moving at the speed of force. Okay, just like all the little bits are doing. Rather than being caused by force-carrying particles, so they call them force-carrying, which is, it's a nice bit of verbiage, but it doesn't really get to the point that it's a force itself, okay? So they wouldn't be force-carrying particles, they would be particles of force, right? And the idea would be is they have something called momentum. So we have these little bits flying around, and when the little bits are, at a frequency, we call that a photon, so that's easy to understand. Frequency means photon. Out of frequency, that is out of order, like this and like this and this and this, that you can understand, okay, that's not a photon, but that's still energy. And, you can understand that, two of them, with a big space, and then two of them would be very different, in terms of what we could receive, but this would still be energy, still the same thing as a photon. It's just not as many of them. Okay, we could sort of understand there could be lots of that stuff, and we could call it cosmic background radiation, we could call it lots of stuff, we could call it heat. They do that a lot. These cosmologists talk about the temperature of the universe and how many Kelvin it is, and that's just saying how much of this little crap is banging around. And you could have this kind of easy understanding that if there was a bunch of stuff coming this way, okay, and there was a thing in the way, and you were standing over here, that, hey, you're going to get hit by all this stuff coming this way, no problem, it can hit you really easy. And the stuff coming this way, though, might have a problem because it might get stuck in here as heat. And we might think, oh, hey, I wonder if the center of the Earth is molten. Yeah. I mean, theoretically, it should be cold, right? Because a bunch of energy is bouncing off of the Earth and doesn't really doesn't penetrate in there. So where's all that heat coming from? Oh, well, maybe that's because it's absorbing all this energy that would have hit here, right? It was heading right for me, but this stupid asshole's in the way, absorbing it, and therefore it never gets to me. And so what's the consequence? I have these three coming from one side and only two coming from this side. What do you think the consequence would be? Oh yeah, maybe this thing will move this way. So when they say force carrier, they think I have to send something over here, and this thing I send says, hey, there's less energy hitting you. So it sends a force carrier to the object that says, guess what, there's less force coming to you. That's how they think of it, because they don't think very well. They're stupid. They're not very smart people, right? They're like most nerds. Yeah, they can do their calculus, but they can't figure out that their waist isn't up here, and they shouldn't tie their belt at their chest line. They can't figure out simple things like that, like not picking their nose or something. So, we've seen these idiot savants before, these nerdy savants. Very good drivers, very good physicists. I'm a very good physicist. No, you're really not, because you're not very logical. There can be something that stops a force from getting to something, and therefore something moves because you stopped one force, but the other force is still there. You see, it's going to make something happen. And all you did was take away a force. You just said, I'll take this away. So you don't need a force carrier to tell it's missing something. The force carrier is actually missing. Okay, the force is missing. Therefore, the other force has more power. Gee, that is so hard to believe that that's how the universe could work, that you could block the force and therefore the other force has more power. Wow. Have they ever considered that concept? No, because it's not in their Bible. If the story isn't in their Bible, they don't know it. They can't imagine any other stories. Yes, I'm being very obnoxious, but this is such fucking garbage. These are supposed to be intelligent people playing an intelligent game, and then they do something so fucking stupid, and you're just saying, how can they be this stupid? Like I said, he describes the Eddington experiment wrong. It's not that complicated an experiment. And he certainly explains it wrong in pointing out how it doesn't prove anything because it was such a marginal experiment. It has marginal fundamental credibility. So anyway, let's do this again. Particles jumping between matter particles. So force carrying, whatever that means. Gravity can be explained as a bending of space. Well, no, it really can't be explained that way to anybody rational, because how do you bend something in 3 dimensions? It's pretty damn hard to do that. And time. So bending of space and time. So somehow there's this time thing that changes. So, well, let's just play with it since it's going to be part of the subject. But, you people really don't get it. You think there's more than one universe, right? There's a bunch of sub-universes where sub-things can happen. You really don't think that every single photon in the universe right now, every collection of photons, of energy or quanta, that's moving at a frequency, that you don't think every single one of them is in a real place and in a real place in time right now, in space and time. That there's real stuff in the universe doing real things, and they're all obeying the same rules. The stuff can never, these little bits can never go faster from point A to B than the speed of light. That's all they can do. They can go a definite speed, and that's the only speed they can go. They can't go faster, they can't go slower in free space. They can't do any of that. And we know that when they go slower in matter, it's not that they went slower, it's that they took a crookeder path, right? They didn't take the same straight line path. Just as we, sitting on Earth, are not taking a straight line path going around the Earth, right? We're right now being accelerated down, and then we're pushed back up, and we're accelerated down, and we're pushed back up. You can feel it happening. It's not a fancy experiment to do. You can feel your ass get sore. Well, why is it sore? Because it's getting pushed up and down all day. That's why. Asshole. Not complicated. So they think that this thing can do something else in the universe. Like somehow I can move and this thing changes. So when two things, like there's a thing way over here and a thing way over here, and they both blow up at the same exact time, they think, depending on how fast I'm going, these two things didn't blow up at the same time. That somehow I'm changing them by looking at them. Yeah, no, I can't change what they are. They are what they are. The universe is evolving independent of your horseshit. So even if you could do this moving the speed of light thing, and even if it didn't destroy your matter entirely, and you could pretend that you're just like a radioactive decay, right? So because radioactive decay, we have proven, radioactive decay is retarded, slowed down by velocity. So the faster you move decaying matter, matter that can decay into, something else, the faster you move it, the slower its decay. So we have pretty good evidence of that relationship. You say that human beings decay the same rate. Okay, so they age by the same exact process as nuclear decay. And so you could slow down your life, you could lengthen your life by moving fast. Well, the only trick is though, okay, is that when you're moving fast, you won't be seeing the same frame rates. You won't be seeing the world. The world will be rushing past you so fast that you won't see any of it. You won't experience any of it. You won't actually live any longer in terms of your experience. The functions of your body still have to be the functions of your body. So if they're slowing down too, if your heartbeat is slowing down and your eyes are blinking slower and everything's happening slower, you didn't live any longer. You just saw a lot less. You saw the same, but what you saw was everything disappear very quickly. You didn't see anything. You saw stuff blur. You didn't see anything coming from behind you, of course, at all. Those photons can't get to you, right? It takes millions or billions of years for them. So if you're going the speed of light, right, the universe is still doing what it's doing. And everything, okay, still is processed in the universe the same way. You're just saying, I saw less of it. Period. That's all. It's just like cryogenics or something. It's just like freezing yourself, slowing yourself down. So there's nothing to be gained from it because time will keep ticking. The universe's time keeps ticking. There is a clock in the universe where each photon is moving a distance, okay, a Planck distance. Each photon is moving that distance by a clock that ticks in the universe. There is a center, okay, there is a fact of what thing is moving, this one or this one. There's a fact, okay, not a fantasy. There's a fact. There's an actual reality to this stuff, and the reality is that you might be able to go to 3/4 the speed of light, but you won't see the same world go by. Your perception doesn't have anything to do with the reality. The reality continues to tick at the universal time, and that never stops. Photons, no photon anywhere, one right next to you, one in your head, doesn't matter where it is, they're all ticking on the same clock. This is all just such bullshit you made up. Oh, I'm just pathetic that you people fall for this shit. So I wrote a list of little just thoughts that popped into my head regarding how to say it to you so you could understand how silly and wooey this nonsense relativity crap is. But we'll get to that later. All right. So gravity can be explained as a bending of space-time. In episode 13, Dr. Lincoln, we'll save that for later. Dr. Lincoln. A doctor of something. Bullshit. Briefly sketches Einstein's theory of general relativity, or our current theory of gravity. So it's ours. We all have this wonderful theory. Our dear sweet Christianity, or our dear sweet Islamabad bullshit. Yes, it's ours. Don't you just cherish it? I just love Islam because it's our Islam. Yeah. And mentions some tests. Oh, so he mentions some tests that that prove it's right. Yeah, no, sorry. You could say that indicate. That might be a fair thing to say. We have some indications. But again, it's built on crap. Because it just turns out that yes, subatomic particles decay slower when you give them velocity, because it's a physical reason, you know. I mean, I could explain it to you, lots of the ways we could understand it, but the simplest one is that you're moving it and say two things have to happen. Energy has to come this way and energy has to come this way at the same moment for, say, this thing to decay. And that's a rare event where it happens at exactly the same Planck moment of time, where a piece of force hits it from both sides. Obviously, when I move it, the odds of that simultaneous event become less and less because the energy coming this way can't catch up and doesn't hit as often. And therefore, you have the A, but you don't have the B event, right? So you just get a lot of A events, but no B event. Boy, you people are stupid. Anyway, jeez, you fall for this crap. Alright, so I don't think we'll need the rest of this screen since I've rid of it.
Over the last dozen episodes, we've talked about all sorts of things that occur in the subatomic realm. But the world of the ultra-small is not the only interesting domain to study. There's also the big, out there. That part of the universe is governed by different rules, different forces, and that is what...
Alright, so you believe that. You really believe that there's something other than one universe with one pile of crap in it. And the little crap is, elemental. Little elemental electrons, you can suspend your fantasy for a minute and understand that the only ones that really mean anything are electrons and protons and the forces that affect electrons and protons, because you know that everything else is a composite. Everything emerges out of electrons and protons, including the neutron. And that all you have is those things, and those things getting pushed around by some sort of quantizable Planck constant force. Some amount of this little bit of thing called momentum or movement. And that's all there is in here. There's just movement at the speed of light, and matter moves something less than the speed of light because matter is more than one piece having to move. And the pieces obviously are doing this kind of thing as they move in a direction, and that obviously that would end up being a lot slower. If you're doing this, you're not going to get all of your energy to get you in that direction. You can't go that way directly if you're dancing, so to speak. So we know that the matter ends up dancing, jiggling, going a lot of different ways, and that it doesn't very efficiently take energy this way and end up having energy out that way. Then it ends up doing it in some herky-jerky way that ends up slowing us down. Duh. So matter moves less than the speed of light. The force moves the speed of light. Not complicated.
What I want to talk about in this episode of Subatomic Stories.
I guess I could turn it up a little bit. This is all these little technical details. Get rid of that. We'll save this up here maybe, just in case we need it. So why general relativity is definitely right. I mean, it's such a bold statement. Why he's basically saying no reasonable person can deny our truth. Why our God is God. And he's going to give us the reason. And again, the reasoning is going to be so frickin' flawed.
In episode 6, I told you about the known fundamental forces, specifically electromagnetism, the strong and weak...
It's probably too loud now, actually. The strong and weak. So again, all these forces move exactly the same speed and do exactly the same thing. They either push or pull something, right? And all you have to do is say, okay, I understand that pull is too weird a concept. Let's forget about that. So they either push or unpush. It either hits it or it doesn't. And when it doesn't hit it, that has a consequence that all the other guys are stronger now because there's nobody on the other side of the rope in the tug of war. That kind of thing. God, I'm sorry, I'm just being so obnoxious, but I'm getting so sick of this shit. These stupid, idiotic people that keep resisting this simple truth, and then they have to keep trying to put words in my mouth. I'm the one arguing that light is consistent in the universe. That's not what Einstein's arguing, okay? So let's just understand. I'm the one saying photons can't interact in any other way but with something that's going to react at the speed of light. That is, it doesn't matter how fast you can't make them go any faster, so they can only be released. And I've used analogies like a bird in a cage. The bird can go in and it's flying. It can fly around in the cage and then you release it. It doesn't matter if I'm going 150 zillion miles an hour. When I release the bird from the cage, he's going to still just be going the speed of a bird. And that's how all the interactions with matter happen. They're always collisions at the speed of light. You can't make them any faster. There's no way to create a more momentum for a photon. It can only interact with a piece of matter that's been affected by other photons moving the speed of light. And so all you can do is make the event happen sooner, or you can make an event happen later. But every single car crash, every crash between forces, that is, every time they are attached to a piece of matter and then they have to get an interaction with another piece of force, every single collision, even in the parking lot, no matter where it is, it's always at the same speed. It's always the speed of light against the speed of light. And it doesn't matter where I put it in space, it's always the same collision. It doesn't matter how fast the matter's moving, because the stuff inside the matter is always being forced by the same thing moving the same speed. They should be able to understand this. This has to do with their whole idea of energy conservation. They understand nothing about physics. It's amazing how they have gotten everything wrong.
Nuclear forces and gravity. Then, and that's
So he puts them here, and you could understand. He could say they all move the same exact speed. All the forces are exactly the same in their character. They either push or they do not push. That's it. They only have two fundamental mechanisms. They are there to push or they're not there to push. And everything else happens in the universe happens because there was either a pusher or an unpusher, an absent pusher.
same episode, I ignored gravity entirely. Why is that? It's because our understanding of how gravity affects the world is very different from how the other three forces work.
That's right. It's even wooier nonsense. So they go from the virtual photon world, right? The force carrier, instead of a force carrier particle thingy notion, the virtual photon that tells everything where to go, to the even wooier explanation, which is the nothing space tells everything where to go. The absent force, the unforce, the whatever it is. The nothing tells the something where it's going to go.
In episode 5, I sketched out how forces work in the quantum realm, but we don't yet have an accepted theory of quantum gravity.
You didn't do anything near that. And yes, you have no understanding that everything is the same force. There's only one of them. There's only one field of energy. It's made of quanta, and the quanta can be in the form of magnetism, electricity, or photons, and, in fact, gravity. Not complicated at all, really. There's a very tiny little thing in the universe buzzing around, little tiny stuff, and it's all the time hitting us. And if I turn a photodetector, if I turn its sensitivity way up, all of a sudden it goes off like crazy. I wonder what that is. What's that? Why is the photodetector going off like crazy? Is that maybe an indication that there's a ton of energy affecting us that we don't see? Oh, what a surprise. Maybe that's gravity. Duh.
In this episode, I want to talk about gravity in the way we currently understand it. Gravity is the most familiar...
We all do this. We, the group of nerds, sycophants, idiots who revere saggy, baggy douche.
of the forces. We encounter it as young children, and we learn to feed ourselves, sometimes without success. It was in the...
So we always need a little bit of humor. Part of the nerd fun.
1670s when Sir Isaac Newton devised his theory of universal gravity.
Right, he found out the obvious thing that was sitting right in front of us, so, sitting right in front of them, so to speak, in terms of why is this moon doing, and why do, if I change where the position is, I have to change the velocity, that's sort of interesting. But the key thing was the inverse square law. That's all. That's the key piece of the whole thing. It's the inverse square law. Just understanding that, yeah, it's like there was a light bulb. It's doing exactly the same thing as my hand is doing, right? So I put my hand here, half the distance. It's 4 times bigger than it will be here. 4 times. See, it's 4 times. It's 1/4 the size here, and it's 4 times the size here. That's what Newton discovered. Now, that's not too complicated, right? I mean, you could do this all day. But see, Newton didn't have a video camera, so he couldn't just... Yeah, but he did have a mirror. You can do it in a mirror, too. It seemed... Well, a mirror confuses you a little because there's twice as much distance, so, But, I mean, it's right there to be seen. You can see little hand. Yeah, see? Little. Twice... 4 times bigger. That's what Newton discovered. So let's understand. That's it. That's all. I mean, M1, M2, big deal. Gravitational constant, that's just putting it into newtons. The force, you don't even need that thing. It's just the inverse square law. That's Newton's formula. The R squared part. That's it. That's the discovery. The force is somehow 4 times less effective here than it is here. Just like a light bulb gets 4 times less bright, okay, as you double your R distance from it.
In his theory, the force between any 2 objects depends on the mass of each of the 2 objects and the distance between them.
And the mass would be relevant. Why? Because mass is sort of like your opacancy, right? I mean, mass is matter in the way of force. So that's what mass is. Mass means you're going to be able to interact with a force. And yes, you can interact with it by transmitting it. Then you didn't interact with it much. Okay, that's just a little interaction. Or you can interact with it by absorbing the energy and having it bounce around inside of you and make you hot. Well, these are all different ways you can interact. And depending on how you interact means the matter will be doing more stuff. But for gravity, the interaction is just simple. You moved the matter. You moved mass. So we move the Earth a tiny little bit. With our mass, we block a little bit from the Earth, and therefore the Earth doesn't get hit by the little bit of energy, and therefore the rest of the Earth moves towards me. Okay, but substantially is what's happening, and the Earth is gigantic, and it's blocking a ton of force from hitting me, and so therefore the force that's hitting me, the light from above, is so much stronger than the light from below that I move down. My matter moves down. And it's happening to the material bits, the atoms. The electrons and protons are the things doing all the moving. That's why they're the mass. And as I pointed out, you can obviously sort of understand the little bits don't move straight. So therefore, they're not very efficient. And, when the rain hits, they don't move exactly as fast as the rain because they end up going in lots of other directions as they go in the direction of the force. So it takes a while to accelerate my mass, because not all of it is complying. Some of it's going this way and it wants to keep going this way. Some of it's going this way and wants to keep going that way.
He even invented a simple equation that quantified his ideas. Newton's ideas are still applicable even 3.5 centuries later.
Well, you can't undo the inverse square law, retard, because it's so fucking obvious. Now, they'd probably like to. They'd probably like to say this isn't true because bent space doesn't do this. But I'm just saying, yeah, you can't undo Newton because guess what? This is pretty fucking reliable. Yeah, so you're never going to undo that. You're never going to break Newton's equation. What you're saying is there's other variables that change how things are going to behave. Well, guess what? The only other variable was Mercury, right? Mercury's orbit is a little bit screwed up compared to the other planets. And the simple explanation, right? It's so dirt simple. Is because Mercury is closer to the sun, okay? It's really, really close. And the simple truth is that all of these other planets, even though they're very far away and all this stuff, they are affecting the sun. And the sun is actually processing in its orbit. Its center of gravity is processing, okay? It's moving funny. okay, because of all the other influences on the sun. So the sun is jittering in its orbit, okay? And we can't see it because, it's a tiny little jitter inside the center of its gravity. So it doesn't really look like the sun's jittering, but it's jittering. All right? And what the simple truth is that jitter affects Mercury a lot more, right? By the inverse square law, it affects Mercury a lot more than all the other planets because it's so damn close. But it's affecting all the other planets, but it's just a tiny, tiny effect because of the distance. So Mercury sees the sun moving funny, and it moves funny in return. And that's the simple explanation. So Einstein's addition means nothing. All you need is some equation that tells you, well, how much jitter in the sun will cause how much jitter in Mercury, but no jitter in the Earth. And there's a number where, yes, you will screw up Mercury, not screw up the Earth. So there's a certain amount of jitter, and I bet you that jitter will come out exactly as Einstein's formula. Same exact thing, simple explanation.
For instance, NASA used Newton's law of gravity to shoot the New Horizons space probe to Pluto, traveling 3.26 billion miles over 9.5 years, and hit a target 10.
Right, just using Newton mechanics, right? Because, guess what? We don't have to worry about the precession of the sun, right? We don't have to worry about little jitters in the sun's gravity, okay? Its center of gravity. It's the gravity that's causing everything else to be where it is, right? And if it's moving, it would be relevant to everything. But obviously, the further away you are, that tiny movement won't mean anything. So Newton's laws work perfectly fine. So no problem. We only need Einstein's bullshit when we're close enough to be affected by the fact that the sun is precessing and its center of gravity is doing this a little bit. The Earth is likely doing it a little bit too, but it's so little that it just doesn't have an effect that we can see.
Miles across. That's impressive. Well, Newton's law of gravity works in just about all familiar situations.
It will work in all situations except situations where there's more variables. There's some other circumstance besides static. I put the sun at this location. I put the Earth at this location. And I assume the locations don't change. So it's only adding more information where you need to understand that there's another variable. That's it. I mean, Newton is fundamentally perfect as long as you assume things have static locations. But if you understand that the sun is moving, well, then you have to account for the fact that the sun's moving.
Fails in regions of very strong gravity, or for very.
So it doesn't fail. So again, it only acknowledges one aspect of a variable, one variable. If some other variable exists, right? So if I can do a car crash simulation, if I have assumptions going in, we know that if we, the laws of mechanics will tell us how fast the cars will crush and all this stuff. But if I change the variables, if I say, okay, they're plastic cars, not metal cars, well, of course the answer is going to be different. It's not because we have a bad theory of mechanics, it's that we have to account for when you're changing variables. So if we're changing the location, the actual location is changing a little bit, then obviously the mathematics becomes a little more complicated because you can't just say it's there. Saying it's there doesn't work anymore.
Precise measurements. That's where Albert Einstein comes in.
So again, there's nothing. Einstein didn't come in. Einstein was given the job. So they just lie about the history. Like Einstein on his own decided to figure out, see if his theory met the standards of predicting Mercury's precession. None of that happened. It's clear evidence that Eddington wrote him, asked him to do it, that Einstein did it because with Niels Bohr he spent 6 months contriving field equations that would predict it. So it's clear the math was completely with that one objective: make Mercury's precession make sense. That's it. That's all it came out of.
In 1915, he released his theory of general relativity. General relativity was a very different way at looking at the universe.
And then he re-released it. So let's understand. He released it and then he fixed it. because the first release didn't have light being bent twice as much by gravity. Didn't have a lot of things. So again, the history is not what they say the history is. They just fluff over it and pretend. They put so many words in Einstein's mouth, it's pathetic.
The nature of forces. Einstein's theory threw away the idea of forces like most of us understand them. Instead, his
simplification was so stupid. I mean, again, it's not a mechanism. He's not explaining how gravity happens at all. He's blaming it on some silly, non-existent mush. It's a silly concept. Bent space is silly. It doesn't mean bent space in 3 dimensions. They can't teach it in 3-dimensional. When they attempt to teach it as a real physical force, they teach it as mock gravity. They teach it as the very thing I'm arguing for, which is hilarious. They teach it as an external fluid pressure. They teach it as a push force.
Showed that what we call gravity is actually the bending and distortion of space-time.
Blah, 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 blah. A magical place gets bent with the magical bending mechanisms and things. The electron says, oh, the space is bent, I have to move. I mean, if that's not religion, what the fuck is it? It's not even a gremlin. It's just some notion that I have to do something because there's bent space in front of me. What the fuck is that shit?
Locations with a concentrated amount of energy bend space more than ones with a low concentration of energy. And
yeah, it's just more nonsense. So somehow photons are twice as affected by this bent space, and the fact is that photons are the energy in the universe, so somehow they should be bending space. So why doesn't things fly into photons? Why aren't they gravitational if they're such masters of this bent space crap, and if energy has something to do with bending space? That's just so stupid.
Mass is a concentrated form of energy. Einstein's
so more blah blah blah. Mass is concentrated energy. Well, it holds energy. Matter can trap energy, but that's all it can do with energy. Sorry. An electron all by itself has no energy. There's only energy in the fact that it is reflecting or transmitting energy. So when it's reflecting energy, it's clearly creating more pressure in the universe. It's saying to wherever the energy came from, back at you, fucker. At twice the force. So the simple explanation is there's, I've been over this, but I just do a brief, the simple explanation for repulsion in the universe is just the fact that, that chalk is now deceased, I imagine. Anyway, the simple argument is that the electrons reflect a certain force, and if they did, you could understand that the force could end up trapped between it, and it would just go back and forth at the speed of light, and every impact would be the same impact, head-on collision, so to speak. And so you would be increasing the number of interactions. The closer the 2 electrons got to each other, the more the interactions would increase. And that would be an R rule, and that's what it turns out to be for charge. So you can understand that pretty simply. And if I created a mechanism where some of the force leaked out, that is, it went out perpendicularly, you could understand how, that could create the opposite scenario. That if I have some way for the force to leak out, that the 2 objects would end up with nothing between them. And therefore the external pressure would end up pushing them into each other. So you can understand the simple mechanism. A permanent reflection creates more energy as the 2 things get closer together. A permanent emission, in one of the other dimensions, that is forward, back, up, down, in, out. If I lost the energy in one of those dimensions, then you can understand why the 2 objects would crash into each other. There, simple mechanics. You don't need bent space. You don't need all this woolly crap.
Equation is monstrously hard to solve, but I've written it down here. We see that it's basically G with some subscripts equals T with some subscripts.
Right, which is just the subscripts mean do 15 million years of bullshit equations, and then you'll figure out what the T equals. Yeah, it's not really a thing, okay? It's a reference to an equation. It's not a reference to a quantity.
Times a bunch of constants. The G side describes the shape of space, and the T side describes the distribution of matter and energy in space.
Right. So it's just basically saying we know there's fields out there. We know there's forces, okay, are creating a field of energy, soldiers. And it's just about what the soldiers are doing will decide where you're going, okay? So if there's soldiers 500 yards away, and I know they're coming in this direction, just like the clouds are coming this way, and I know I'm going to get rained on, in the future. Not very hard to see these relationships, that obviously the matter moves where the force tells it, okay? So they turn the force into something called bent space, but it's the same thing. I mean, the matter is going to go where the forces tell it to go.
The equal signs is key. It says that the distribution of mass and energy equals the shape of space and time. Well, times some constants.
So that's sort of mush, right? Because we know they're not in the same form or anything else. So just kind of silly. So they use this as this is an intelligent quote. Space-time tells matter how to move, how or why or what. Just like I said, an electron is sitting somewhere. You're supposed to imagine that the space-time, whatever the fuck that is, says you have to go forward. And that's what they've turned physics into. It's less than a gremlin. It would make more sense if they said the gremlins pushed the thing. The gremlin snuck up behind the electron and pushes it. Would make more sense. Matter tells space-time how to curve. Right. Yeah, right. It's like having, it's like what? Rocks tell people how to think, and then people tell rocks how to tell them what to think. Yeah.
A famous physicist by the name of John Wheeler summed up these equations with the phrase, space-time tells matter how to move, matter tells space-time how to curve. Now, there are people who...
So they make jokes about all this shit, right? Nobody understands quantum mechanics, this big joke. It was also a big joke. Nobody understands Einstein's theory. So they make the same joke about both of their fundamental theories. Both of them are incomprehensible piles of shit. And they joke about how they're incomprehensible piles of shit. And yet you people will sit there and badger me with how I must believe, I must.
don't believe in general relativity. But general relativity has been tested, and there's no doubt that
Okay, it's been tested. Yeah, okay, to some extent. A tiny little extent. Very peripheral ways, right? Like you're proving... I don't know, you prove somebody has a college degree because they know what a hippocampus is. Yeah, that's our proof. So if you know what a hippocampus is, if I ask you what's a hippocampus, and you know, then there's a correlation that you went to college. Okay, so it isn't guaranteed, right? Because I know what it is and I didn't go to college.
it works very well. One prediction of general relativity is that the path that light follows should be bent by gravity, even though light has no mass.
Right, even though light has no mass and it's moving the speed of fucking force, preposterous speed. It's not, so he didn't even say it truthfully, right? He didn't even honestly say what the real theory is, right? So another one of their fucking lies and bullshit. Einstein's proposing that light is bent twice as much as every other material object. So all the matter bits are moved, but light is moved twice as much. So the thing that's the smallest thing and the thing that's moving the fastest is somehow affected twice as much by what bent space says. It hears bent space's message twice. Like photons have two ears and one ear hears it, and it really, they said, bent space only said it once. But because the other ear is on the other side of the photon, it showed up there a little bit later, and the photon got confused and said, move left! And then it heard move left in its other ear, and it's, oh shit, I gotta move left again. So photons move twice when bent space says so. Ooh! That's their fucking truth based on absolutely no rational reasoning. The rational reasoning is, Einstein said, I have to make all movement equivalent. Okay, it doesn't matter whether you're being poked by a bullet or you're being poked by a million feathers moving the same speed, I'm going to make you react the same way. Obviously, you're not going to react the same way. It was stupid to think so.
The second is that clocks in strong gravitational fields.
So clocks, this isn't a word. This doesn't mean anything. What he means is radioactive particles. Yeah, right. Okay, so that's what he means. Atoms of radioactive material. Okay, there's no such thing as a clock, right? I mean, a clock is a machine that you can make out of a lot of different things. It just measures the processing of the universe. We know the forces move a certain speed. If the force is moving in the circles this fast, in a circle this big, then it'll take a certain amount of time for it to go one circle. And if it's a bigger circle, then it'll take more time. So you can make different kinds of clocks that run on different kinds of mechanical processes, but they run on mechanical processes. So he's talking about one specific kind of clock. Not sundials, not sand dials, not sand, what do we call those things? Hourglasses, not pendulum clocks. When he says clocks, he doesn't say what kind of clock. So it's a specific kind of clock that does what he wants it to do.
Should run slower than ones in weak gravitational fields.
So we know that we have no real clocks doing that. That is common clocks. And the only clock we can make that has a tiny enough second hand, a millisecond hand, a trillisecond hand, it has the right hands on it. The only clock we can make that has the right hands is unfortunately dependent on radioactive decay. So all we can do is say what radioactive decay clocks do.
The first impactful test of general relativity occurred in 1919 and demonstrated the ability.
So he brings up this stupid clock thing and then brings up Eddington. So he should have brought up Eddington first and then talked about his silly clock crap. This Eddington doesn't have anything to do with clocks.
Of the sun to bend the passage of light. Sir Arthur Eddington took advantage of a solar eclipse to block the light from the sun.
Took advantage of. Right, and not a very good one, right? Nothing like, not even close to the great eclipse. His eclipse was a 2 o'clock in the afternoon or something. We had the perfect one over North America. 12 noon. Ooh, perfect eclipse. And did nothing with it.
With the sun blocked out, he could see the stars behind it.
Okay, so there we go. Just too fucking big an error, a lie, a horse shit. Right? So he's not going to tell us anything about the fact that Eddington was expecting to get 10,000 stars on his photographic film and got 1,000. So it was 1/10. It's like his telescope got 1/10 as big, pretty much. His telescope shrank, into a little tiny telescope because of the weather. So he had horrible weather. It wasn't just bad weather, it was horrible weather. Let's just not include that fact. Oh, because that's not important. Facts aren't important to any of this crap, right?
He knew where those stars.
But look at this drawing. Eddington did not. He looked outside. He knew you had to look outside the sun's corona. Okay, he was smart enough to know. Oh yeah, that's just going to get me scatter, and I'm not going to see anything anyway. I can't see too many stars. Even with the eclipse, the corona is a real problem. So we all, look, even if you eclipse out the sun, right, you block the sun, well, the problem is its corona is way out here. And this is full of little particles, okay? Just tons and zillions of them, little pieces of energy. All that stuff you see that, when heat rises in the atmosphere and you see all that wavy shit. Yeah, this has a whole bunch of that wavy shit in it. So obviously you can't do some precise measurement in here. So your only hope is to do it out here. Now the problem out there is that, you're further away from the sun, so it's less gravity, so you get less bending, which sucks. But Eddington was not looking at anything behind the sun. He was looking at something that should be here, and he was hoping to see it here. That's the difference, right? It's not a big difference, and it's certainly nothing to do with a star that was behind the sun. He wasn't seeing a star behind the sun and blah, 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 blah. None of that shit was happening. All right, so this is all just a lie. And again, not pointed out is that, oh yeah, and if it wasn't for this 2x increase in in light being bent twice as much as every other material thing in the universe, if it wasn't for that fact, this would be a mathematically impossible experiment. So, you wouldn't be able to see. The locations wouldn't be far enough away, and you wouldn't be able to see anything. You wouldn't be able to calculate this distance because your error rate would be much higher than you wouldn't be able to overcome the error in your calculation. So without this 2x thing, you couldn't even see this shit. And again, so the Eddington experiment was horrible data. The analysis was done poorly. There's lots of accusations of, oh, well, this image didn't show what we wanted. This plate showed Einstein wrong, so we just didn't include that one. Lots of evidence that actually happened. This plate doesn't prove Einstein, therefore we're not going to... It's broken, okay? This plate's broken because this one doesn't indicate what Einstein said is right. So this plate, we'll just pretend as I cracked it, and therefore it doesn't have to be included. There's hard evidence that that's what actually fucking happened, and yet they see citing this as why it's proven. We all have to believe it. Trust me, trust me, trust me. This is so well proven, so well documented by an experiment he can't even draw correctly. It's not that complicated an experiment. You can't draw it correctly. And you believe these fuckers. You believe these assholes when they tell you all this stuff about what they have proven. How their gravity wave machine works, how everything works. And this is how they draw simple experiments. They can't, for their life, they can't, to save their life, to save their reputation, they can't draw a single elemental experiment correctly. They can't draw the two-slit right. They can't draw gravitational lensing right. And we're all fucking evil assholes because we don't believe these fucking insanely up their ass nerds.
Should be if relativity was or was not correct, and he saw them where they would be if Einstein was right.
But you won't be able to see it. Okay, you won't see it. They won't show it to you. Why didn't you show me the plate and show me the star that's in the wrong place and all that shit? Oh, that's right, because the evidence is so bad that you really can't make the argument. You really can't defend the assertion because the actual physical evidence sucks. And that's the truth. This evidence sucks. It's weak, crappy evidence. And yet you're making this claim. You have to believe us. You have to believe our God is God. We've proven Jesus walked on the water. Eddington walked on the water. Einstein is God.
Also been several tests of how the strength of gravity affects clocks, but I have a favorite.
Oh, I have a favorite. And I was going to bring up GPS, which wasn't a discovery. It didn't make Einstein right. They won't show you any perfect equations, right? It's not going to show you how Einstein's equation perfectly predicts the exact time dilation of the clocks because that's not how they figured it out and that's not how they adjust for it. They don't use Einstein's formula. They adjust the clocks based on how much they're off. They don't bother doing all these calculations. So it's all a pile of horseshit. But the fact that the clocks are based on radioactive decay, there's clear evidence, okay, that you can slow the decay down of objects. See, they talk about muons, but muons are not decaying like radioactive decay. They're not decaying into another substance. They're not creating radiation. Okay, so this is decay of like uranium or something. We're talking about the decay of an atom that is unstable and that you can slow its decay down by moving it. And the simple argument I'd make to you is that, of course, can make sense. Because if I'm moving something, the same conditions don't exist for it. It's getting more energy from one side and less energy from the other side. So if there's some sort of simultaneous event that has to happen, you can understand that that simultaneous event won't happen as often. So you can understand that movement changes the environment that the radioactive element would be in, and that could decay its conversion into two subatoms. That's not a bizarre explanation. That's not out of the realm of reasonable, and yet you've all claimed that you've somehow proven it can't be that as the answer. So all they have as evidence of Einstein's theory is the fact that radioactive elements are affected by velocity. They haven't proven that anything called time breaks.
Researchers at the National Institute of Standards and Technology in Boulder, Colorado, had two extremely precise clocks So precise that they lose about 1 second every 3.7 billion years.
All right, so again, this is all just the same thing, so I won't bother playing it because we've already been over this crappy evidence. This is just evidence that you can affect radioactive elements by moving them. It's not evidence that Einstein's theory that there's a bent space demon bending something or warping something that causes matter to move is in any way an accurate description of the reality. All right, so I'll just get back to my claims about light and the fact that I'm the one asserting that light is the universal clock, that no photon in the universe ever travels anything other than the speed of light, the speed of force. The bits inside of it, that's what they do, that's what it is, and they're all exactly doing exactly the same thing no matter where they are. You can't put them in some frame where they change what they do. They're always doing the same thing. Photons always move from point A to point B in a straight line unless you put something in their way. Anyway, photons do not exist in anyone's frame. Yeah, so you can't have a framed photon. There's no my photons are different. So if I'm moving into photons, okay, those photons don't change to acclimate to my movement. Okay, there's nothing that changes about the photon. The photon is the thing coming at me at a speed, and there's one behind me coming at me at a speed. I can't do anything by moving this way or moving that way, okay, to change what these two things are doing. They're going to go from point A to a point B to a point C to a point D in space. That's what they're doing, okay? They're both doing their thing. They're moving their way, okay? And I can't do anything to change what they're doing. I can only see them different. So by moving towards one of them, I can get to a location where I'll interact with this force sooner. Or I can change my location and interact with them later. But that's all I can do. I can't do anything else to them. I don't change them. Okay, and obviously for my atoms, the circumstance is a little different. Like I said, your atoms already contain energy. That means they're already being propelled by forces that are moving the speed of light. So from their perspective, they're already moving the speed of light. When I'm here, when I'm here, when I'm here, it doesn't matter where I go. When I interact, the interactions will always be at the speed of light because the stuff inside of me is already moving because of forces moving the speed of light, because of the electricity and the magnetism and all the forces moving the speed of light. They're already going the speed of light. They can't go twice the speed of light. Okay, they can't have an interaction at any twice speed. All they can do is have interactions at different places in space. And that's it. But there's no mystery here. Of course, I'll see something different. Okay, if I'm relying on photons to define my perception of two events, but I don't change the events. All right. Photons travel in one space where all distance and all time is measured the same. That's right now. There's photons going in certain places. I go a zillion miles away, and there's photons going to certain places. They're all going in certain places at a certain speed. They're covering distance at a very specific speed, and that's it. And it never changes. There's no place in the universe where it's happening any different. It's all happening right now. Tick, 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 tick. Distance is being traveled by photons. Tick, 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 tick. They're doing it right now everywhere. That clock is the same clock everywhere. All right. Photons care not what care not what emitters or receivers are doing. So you can't change the photon. So again, it's the bird analogy. The photon is captive to what matter is doing, but it's never, or the energy. So we're talking about photons, but we're really talking about all forces. And the idea is that you can't make it go faster. So if I capture a bird in a little cage, and the bird just flies around in circles in the cage, it doesn't matter how fast I go, it just changes how the bird flies, right? So if I'm moving in this direction, then the bird doesn't have to fly this way very much. and he has to fly a lot more this way, and then he flies less this way, or vice versa. You know what I mean? It has to compensate for the movement. So because the cage is moving this way, the bird flies longer that way to get to the other side of the cage, right? Because the cage keeps moving away from him. So the bird flies longer going this way, and then flies much shorter going this way, and then much longer this way, and then much shorter this way. So the bird's just flying in the cage. And so I can go a million miles an hour, right? And the bird is still just flying. And when I release him, that's all he has is his speed. So he's going, say, 30 miles an hour. Well, when I release him, he won't be going a million miles an hour. He'll just go his 30. Just like the Earth, if you release it, it's just going its velocity around the sun. That's it. There won't be any extra velocity. It's just the velocity, the release velocity. It doesn't matter how fast or slow anything else is moving. It's the release velocity. So force is always released in all interactions with other force at exactly the same velocity. It never releases faster than the speed of light. The photons never emitted 1 million miles an hour plus 3 million miles an hour. No, that doesn't happen. Well, 168,000 miles an hour. All right. Let's see what else is on here. Photons do one thing. They travel a standard distance in a standard time. So all of them are doing the same thing. All the forces are doing the same thing. They just move distance, and they move it all at the same amount of time it takes all of them to move that distance, and that's it. Nothing else can happen to them. Events happen at a time in space, not in any place called space-time. Yeah, there's no place called space-time where you get to have an event. There's just space. There's just stuff in the space in specific locations, and you just can't break that. All right. The universe evolves everywhere by the same rules, clock. So the same clock is evolving the universe. It's ticking. Tick, tick, tick. The little Planck ticks of a photon moving an infinitesimally small amount of distance. Tick, 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 tick. And all the photons are on that same clock. All right. The clock of events has no irregularity. There's no place you can go where you change any of it. There's one universe. Everything's moving in it. And you can have a bunch of energy that's moving you in a direction, but it's because you have energy that's moving you in that direction. You have it. You've stored it. You've taken it. Just like when the wrench flies through space and tumbles on and on and on, there's energy in the wrench making it spin. There's energy in the wrench making it go in a direction. It has forces in it pushing it constantly to do that. It's captured the force. The space shuttle captures the energy of the flame coming out of the back end. Energy equal to the flame coming out of it is going in to the physical structure of the shuttle. That's why it continues to move. Because it's trapped it. The space shuttle on the ground is fundamentally different than the space shuttle moving in space. It's completely changed what forces are inside its atoms. Okay. Photons never move a distance slower or faster. So in free space. So again, the only way you can make photons look like they slow down is to transmit them through a medium, to force them to go kind of a funky direction to get to the point A, point B. Well, there's a point A sub 1, A sub 2, A sub 3. There's a bunch of points in between that the light had to go through to get to point B. And that's why it looks slower. All right. Reducing your frame rate of perception is not living more. So I sort of dealt with that in the beginning, but this idea that our metabolism would slow down exactly at the same rate as decay slows down, right? So atomic decay somehow would have the same velocity, would have exactly the same effect on our decay. when you can physically understand that's not going to be the truth. That if I move you, I have a bullet in space, it's just sitting here minding its own business, and I move you at 10,000 miles an hour towards the bullet, you do understand that all of a sudden this bullet's just going to bore a hole right through you. It's something very different than if I just walk up to the bullet and say, "Hi, bullet," and push on it. That event's going to be completely different than the event at 10,000 miles an hour where the bullet's going to go right through me, even though it's just standing still, minding its own business. Right? So we know about this relative motion shit. That's not complicated at all. Yes, it doesn't matter whether the bullet's moving 10,000 miles an hour or whether I move 10,000 miles an hour into the bullet. It doesn't matter. Those two events will be the same because it's just the difference in the speed. And so we know that's all that matters. That's not complicated. You can believe that without this whole relativity shit. That's simple relativity. It's sensible relativity. But that's all there is. Anyway. So, this idea that by moving, that you, like I said, if you're moving with, if I'm moving and I have, and I turn a headlight on, so I'm moving half the speed of light and I turn a headlight on. The fact is, for me to see that light move away from me at the normal speed of light, I would have to be so slowed down in my perception of reality, right, that the rest of the universe is still ticking. And years could go by where I thought it was a week. That kind of thing happens. So the faster I go, the longer it takes in time. So if I'm going 99% the speed of light and I turn my headlight on, for me to see the light move away from me at the normal speed of light, I would actually, billions of years would have to go by. So a second would have to get to be a billion years long for me to see it that way. So understand, it can't change these facts. The physical universe isn't doing this perception thing. The fact is that in real time and space, if I'm moving and the light's moving, the speed of light, that I will in fact not see it move away from me at the speed of light. It will move away from me over time, but it'll take it a really long time because, like the tortoise and the hare, the tortoise is still moving. Yes, he's slower than the rabbit, but he's still moving. Okay, so the relative difference between their distances isn't going to be the same as their real move speed. And the relative change for me to see it at the speed of light would be billions of years. Alright, atomic clocks are just a kind of clock, so that has to be emphasized. Regarding decay with velocity, retarding decay with velocity does not prove time was changed. So kind of obviously, the fact that decay can be retarded, slowed down, the decay of an atom, does not in any way necessitate the existence of anything called bent space. Alright, changing decay rate does not change all physics and chemistry. So you're not going to change your metabolism, you're not going to change your physical structure, you're not going to change the fact that if I do accelerate you at half the speed of light, that every dust particle that you crash into in the universe is going to be like an explosive bullet. It's going to blow holes all through you and rip you to pieces. That will be a fact. So even in Einstein's silly thought experiment of the spaceship, moving half the speed of light, if we ever made such a spaceship, the actual single little hydrogen atoms in space would be blowing holes in the ship all the time and the thing would disintegrate. If I have you, if I move you fast, I will, you can, I don't know, if I move you fast, something, it will have in you. Well, anyway, it doesn't matter. You will not have the same interaction, right? So movement does change when you're having an interaction. It doesn't change the interaction. All right. Unlike matter, you can't not change the relative momentum of a photon. So you can't change its momentum. The photon always interacts with everything exactly the same momentum, a quanta of energy, and that's it. Doesn't matter how fast it's moving or anything. So on the subatomic level, there's no bullet that you can run into and make the bullet do something different. On the subatomic level, all the bullets are already moving the speed of light, and all you do is change where they hit each other. You can't change how much momentum they have. Hitting each other here will be exactly the same as hitting each other here and hitting each other here. So for their world, it can't make a difference. Energy can only be converted as quanta, and it's irrelevant how fast the matter itself is moving, because how fast it's moving just says how much force it has in it going in a direction. That's it. It doesn't tell you that it has more force. It just that the force has a direction. Okay. Unlike matter, you cannot change the momentum of a photon. It always interacts with a force exactly the same speed, going exactly the... so I changed it interacts with a force, because obviously forces don't interact with forces. But there's always the conduit of the matter, and the matter is always being moved by a force. So the matter just has the force's speed and momentum. So the crashes are all at the speed of light on the subatomic level. On the real level of the universe, all the interactions happen exactly at the same momentum, at the same speed. And all you do is change. If you're moving a piece of matter, it means you have more force going this way inside the matter. So obviously a force this way is going to be impacting a force that's going the opposite way. There's much more of it. And so obviously this force isn't going to have much effect on something much, 10 million quanta going this way, and one quanta going this way is not going to equal going that way. It's going to equal still going this way a little slower. All right. So anyway, enough of the video. It's not my favorite. This is, to me, an irrelevant subject. I mean, bent space is a silly, stupid explanation. It's completely unmechanical, completely useless. And yes, it will never be. It will not survive. As it'll be the first one to be realized as horseshit, because it is so unmechanical, and it won't. And they'll never blend these two theories without making them both even worse. They'll have to make them both worse in some wooey way to ever fit them together. And so bent space is the dead theory. I mean, it's just too stupid. But in demonstrating it, like I said, you can explain gravity without it, and the only thing you have to explain is drag, and that's an easy explanation to provide. So, it doesn't take too much thought to figure out how you get around it. And they just never did the thought, because they never did anything mechanical, and they never believed in anything real. They're just religious kooks, and they've evaded paying any attention to the fossils and the evidence for evolution, for the simple particle theory that explains all this crap, and without all this woo. So anyway, enough. Blah, 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 blah. I'm sorry, you people are silly. And yeah, you'll never admit it, right? But you have to admit that, oh man, I was so suckered. And none of you want to admit you were so wrong about something so obvious and so simple and so catastrophic, in the sense that your whole worldview has been horseshit your whole life, because you believe these idiots, and you believe them right when they do shit that is too stupid right in front of you. They show you they have no credibility. Again, not being able to properly diagram Eddington's experiment is such a fundamental error. Like, Eddington saw a sun behind our sun. He didn't do that. And he didn't do it for real hard good reasons, because it would take way too much bending in the location he had to look. The sun can't bend light that much. It can't physically do it. The experiment can't be done. You have to look in the corona to do that. And obviously no one's done that either. But anyway, with radio waves, yes. But that's scatter. So again, it's just such a fraud that these people, and they show you they're fakes. They show you how fake their physics is, because they can't draw the two-slit pattern right, and they can't draw Eddington's experiment right. They can't draw a magnifying lens right. They can't draw any of it right. And these are simple, elemental pieces of the physics. Why do you believe them? They have the tires of the car on the roof. Okay, they're drawing you, this is the car that made us believe in motion. And they have the tires on the roof. Why are you believing them? All right. So, till the next time and such.